Today, we are getting right to the heart of the engine, the block itself. It's this absolute masterpiece of engineering that has to survive some truly hellish conditions. So how do you do it? How do you build a core that can withstand an inferno? Well, it really boils down to two fascinatingly different approaches: shaping it from liquid metal or sculpting it from a solid chunk. Let's get into it.
Here's our game plan. First, we'll get a real appreciation for the insane conditions this part has to live through. Then, we're going to explore the two main ways of making one: forming versus carving. We'll see how the best of both worlds get combined, and then we'll wrap up with 3 key takeaways.
Okay, so to really understand why these things are made the way they are, you first have to wrap your head around the absolute inferno they're designed to contain.
Just think of the engine block as the rib cage of the whole operation. It's the main structure that holds the cylinders, the cooling passages, and all those moving parts, keeping everything in perfect, rigid alignment. But, its job is anything but static.
Get this. Inside a Formula One engine, the combustion process creates these instantaneous gas temperatures that can spike to 2,600 degrees Celsius. I mean, that is just unbelievably hot, and the block has to contain that explosion hundreds of times every single second.
And it's not just the heat. Look at this. Every time a spark plug fires, the block has to endure this immense repetitive force. We're talking about a pressure that's like having 4 elephants jump on a single piston over and over and over. That's the kind of stress it just has to soak up without even flinching.
So, that brings us to the big engineering question, right? How do you build something that can handle all that abuse, but is also lightweight and has all these incredibly complicated internal passages? Well, that challenge has led to 2 very different ways of thinking about manufacturing. This challenge, it really sends us down 2 completely different roads. And it all boils down to one fundamental choice. Do you build the part up from a liquid, or do you carve it down from a solid?
Let's break that down a bit. On one side, you've got casting. Think of it like making Jell-O. You pour liquid metal into a mold to get a shape that's already really close to the final product. On the other side, you have the sculptor's approach. You start with a big, solid block of metal and just cut away everything that isn't the engine block.
So, let's check out that first path. Casting is, by far, the most common way to mass-produce engine blocks, and for a really good reason. It's just incredibly efficient for creating complicated shapes.
The process itself is pretty simple to imagine. First, you create a mold, which is basically a negative impression of the block, and it's often made from tightly packed sand. Then you pour in the molten metal, you let it cool down and get solid, and then you just break away the sand mold. What you're left with is the rough casting, which then gets cleaned up.
And here's where this ancient technique gets a super high-tech upgrade. For really high-end engines, like in Formula One, they now 3D print the sand cores. These are the really intricate internal pieces that form those complex cooling passages inside the block. Better cooling means more power, and this tech lets them create pathways that were physically impossible to make before.
This quote from Keith Denholm at Granger & Worrell just nails it. 3D sand printing lets engineers design these incredibly complex internal shapes that used to be a complete fantasy. It's literally like being able to build a ship inside a bottle.
But casting isn't totally straightforward. As that molten metal cools down and solidifies, it actually shrinks. And different metal alloys shrink by different amounts. So engineers have to be incredibly precise in their calculations, building that shrinkage right into the mold design to make sure the final part is the right size.
All right, let's switch gears and look at the total opposite approach, the subtractive path. This is what you do when what you need is ultimate, absolute strength and precision, especially in the world of top-tier motorsports.
A billet block starts its life as a huge, solid brick of super high-grade aluminum. Then, a computer-controlled machine, a CNC machine, meticulously carves away all the extra material, layer by tiny layer, until only the engine block is left behind.
And the result of all that carving is a part with just incredible strength and precision. See, because it's carved from one solid, pre-treated chunk of metal, its internal structure is perfectly uniform and dense. There are no tiny microscopic air bubbles or what engineers call porosity, which can sometimes be a weak point in cast parts. This is exactly why it's the go-to for the most extreme racing engines out there.
But all that perfection comes at a really steep price. The process takes a ton of time, which makes it super expensive. And it's pretty wasteful too. Sometimes more than 60% of that original expensive block of aluminum ends up as little metal shavings on the workshop floor.
So all of this brings us to the real-world solution.
The one used for most engines you see on the road today. And it isn't a strict either-or choice. It's actually a brilliant combination of both methods.
I mean, it makes sense, right? If one method is super efficient and the other is super precise, why not just use both? And that's exactly what happens. The vast majority of engine blocks are made using a hybrid approach, which really does give you the best of both worlds.
Here's how it works. First, they use casting to efficiently create the complex overall shape of the block. Then, that rough casting is moved over to a CNC machine, which then provides the final, critical precision on all the really important surfaces, like the cylinder walls, the flat deck surface where the cylinder head bolts on, and all the little bolt holes and threads.
Okay, so let's try and distill this whole process down to 3 really crucial takeaways about how the heart of your car's engine actually gets made.
First, and this is the big one, remember that in engineering, form always follows function. All the complexity of an engine block isn't just there for show. Its entire design is a direct and necessary response to surviving that incredible heat and those elephant-sized pressures we talked about earlier. Every single feature is a carefully engineered solution to a brutal problem.
Second, it's all about trade-offs. The two paths we looked at really represent a classic engineering problem. You're always trying to balance speed, complexity, and cost, and you just can't have the best of all three at the same time.
This is the strategic choice that engineers have to make. If you're building millions of regular cars, well, efficiency and cost are everything, so you're going to lean towards casting. But if you're building an engine for a top-fuel dragster where performance is the only thing that matters, the incredible precision of CNC carving is worth every penny.
And that brings us to our final and maybe most important lesson. The best solution usually isn't one or the other, but an intelligent combination of both approaches. This synergy, using casting for the heavy lifting of the complex shape and then using CNC for the critical, final details, that's the real key to manufacturing high-quality, reliable, and affordable engines for all of us. It really is the best of both worlds, working together in perfect harmony.
You know, it really makes you wonder, doesn't it? How many other everyday objects that we just take for granted are actually the product of this exact same elegant combination of forming and carving, hiding their complex origins right there in plain sight?